Today we're going to start interacting with the file system and also maybe if there's time, just a little beyond the file system. Unfortunately, the way that the book covers this is not, I'm not terribly pleased with. So I'm not directing you to any specific readings on this. There are two classes in Java that I'm going to talk about today. Let's see what they are. They are the file class. What the file instances of the file class represent a programmatic way of representing what's kind of out there. And what's out there, for now, it's just gonna be the file system. But the file class can also be, well, yeah, we'll sort of stick with that. There's actually a URL class which can interact with the internet and other stuff out there. And we're going to start interacting with the file system by reading a text file. And I think this was a class, the scanner class, which is in Java, is a very nice way of reading text files. It's not so good at reading binary files. For reading binary files, you have to kind of go a bit under the hood. And regardless, if we're dealing with a binary file, depending on what the format of that is, you will typically need a third-party library in order to deal with that. Examples of binary files might be like a Word document, an Excel spreadsheet, a database, a PowerPoint presentation. I mean, there are libraries. In fact, there are even open source libraries to interact with all of those. It could be something like a PDF file. Again, whatever binary format there is, will typically require a third-party library, and we haven't yet talked about having these third-party libraries. Toward the end of the class, the quarter, we'll maybe take a look at some of those. There are bazillions of them, just as there are many, many different formats of binary files. So it would be not reasonable to expect a programming language to be able to interact with every single one of those. However, Java actually provides some very nice capabilities for interacting with compressed files like zip files and gzip files. Again, hopefully toward the end of the quarter, we'll talk about some of that. So in other words, what that means is you can grab a file which has, say, been zipped, and you've all dealt with zip files, and programmatically you can unzip it and work with the contents. But all that is for later. So we're going to look at this scanner class, which is a very nice way of reading in from text. Okay, so the file class, and again, there's a little bit of discussion about this in the IO chapter in the book. The problem is that the problem that I have with the chapter is that the author, first of all, kind of directs you to this library that he wrote. And, you know, that's basically a third-party library, and it's not really needed. And furthermore, the scanner class that we'll talk about in a little bit is something which came on, I think, after this book was written. So it was something that the author was unaware about. Nevertheless, in my experience, I found the scanner class to be really the most the easiest way to read in from from some kind of output. Okay, coming back to file. So an instance of a file refers to files on the system. So a file object, we can instantiate one, and there are there are a few more constructors, but these are kind of the main ones. Important to understand, a file object may refer to a file that does or does not exist. So if I have a file object and it's not null, obviously a null file, if I have a file variable and it's null, then obviously it can't refer to anything, because null doesn't refer to anything at all. But can you think of why it might be useful to have an object of type file that refers to a file that doesn't exist on the file system?
Maybe you want to create the file.
So why might that be a useful thing?
If you want to locate data in a specific place where it can't be messed with and then call it back later.
Well, once it refers to a specific place, then that's there. Now, what the file, I mean, you raise a good point, maybe not what you intended. If the whoever's running the program doesn't have permissions, say, to either read to read the file, and that's possible, then that is preserved. That is, the file object will respect the fact that in other words, there may be situations like, for example, certain system files that you can kind of see that they're there, but you can't do anything to them. But supposing I've been focusing on sort of reading things. What if you wanted to create a file on the file system? So the way we would do this programmatically, and we'll do this at some point. Right now we're just reading, but at some point we're going to be writing as well. So the idea is to create one of these file objects that refers to a non-existent file because we haven't created it yet, and then we can programmatically create it. So so when you have a file, this is kind of important to understand the difference here. A file object reference programmatically can be null or not null. If it's null, again, it doesn't refer to anything in the program. If it's not null, if it's an actual instance, then it refers to something specific in the program, but it may or may not refer to something specific that exists in the file system. And that's important to understand. Because then if you get a file object, and this will come up when we're trying to read a file. So programmatically, we're creating this file, one of these file objects, and Java will happily create that file object to you, even if it doesn't refer to something that's there. If we go to read a file and the file object we have is not referring to anything on the file system, then obviously it's, something's going to break. So for the purpose of writing to the file system, or maybe appending to a file system, for example, if we have like a log file and the file already exists, but we want to add some new stuff to it, then at some point we're going to need to be writing to it. And when you start writing to a file, if it doesn't exist, then again, if it's done very carefully, then it will create it. Okay, so here are there are a number of different constructors. Java has a fairly sophisticated way of dealing with what are called locales. In other words, Everybody here in this class is from the US, but in past classes, we've had students from other countries. And in the other countries, there are different character sets. There are different conventions for, say, representing numbers. So for example, here in this country, if you were to represent a large number with decimal places, then every 3 digits to the left of the decimal place, there would be a comma. And when you hit the decimal, we would put a period, and everything to the right would be the decimal piece. However, in Europe, they're flipped. In Europe, there would be a period every 3 digits to the left of the decimal place, and the decimal place would be represented by a comma. So, and we won't go into that, and you're not, since we're all here from this country, where you're not really responsible for that per se, but just be aware somewhere that there is the possibility of specifying a locale, and some of the other file constructors have ways of specifying that, and that was just a little bit more than I wanted to get into. So we're dealing with the US locale, the US character set. And it is UTF-8, not, in the old days, there was something called ASCII that was very constrained. UTF is, especially UTF-16 is very, you can do a whole lot of stuff with that. Anyway, the 3 main constructors. Oops, this is, okay, the workhorse is just to have a path to the file name, which can be either it can be either relative or absolute, and it can be either exist or not exist. We'll see an example of that. There are other, okay, so these, I left out the string here. There should be both of these should have strings in them. Okay, so yeah, here's the other thing, is that a file object can refer to either a file or it can refer to a directory. If I have a file object that refers to a directory, then this way of representing the file refers to a file of this name, the child name, in the parent directory. So the parent file has to be a directory, and this will refer to, well, this could actually be a file or a directory. And I can also do it with just the name of it. I personally find this one, sometimes it's necessary to use the string. Whenever necessary, whenever possible, it's generally preferable to use the object file rather than the string, which is just the name of it. Because the file object is more, it's actually more reliable. The problem, an issue kind of comes up, which is how do you represent the path separator? Some of you are on Macs. I don't know if any of you are on Linux or have dealt with Linux. And some of you are on Windows. And here's the difference, is that on a Mac or a Linux, when I want to separate things, I use a /. If I'm on Windows, though, they use a /. In Java, depending on which platform you're on, if you're on a Windows platform, you can use either one. I recommend always kind of using this. And it turns out that if there's some doubt about that, then there's actually a variable. I believe there's a static variable in the file class itself that is which one of these characters you use. Nevertheless, even if you're on a Windows system, it's always preferable to use the / rather than the /. Java will always work correctly with the /. On Windows, it will work with the /, but that this will fail on Macs. So that's a platform specific thing. If you stick to /, then you can never go wrong. Okay, the file class is an extremely rich and powerful class. It has a whole pile of things you can do with it. But here are the ones that I've found to be most useful. Okay, one is it will give me a string, which is the absolute location on a file system. It will also give me a file object that does that. That can be useful when I've created my file object with a relative path. And we'll see what the relative stuff is about. In other words, I don't always have to specify the total location, which is from the root of the file system all the way down to where I am. I can kind of start where I'm running the program and go relative to that. We'll see that when we look at an example. And sometimes especially in debugging, I want to say, okay, I've gotten a reference to a file with a relative path, but I want to be sure that I'm actually pointing to the actual right one, and that way this string, which gives me the absolute path, will tell me exactly where it is on the file system with an absolute path. Okay, this Boolean exists. This is one that when we're reading a file, one of the first things we want to do is verify that it actually exists. Otherwise, we're just going to start getting errors. So we want, as a programmer, you want to be, you actually do want to be somewhat OCD in the sense that you want control of that. In other words, any errors or any problems that arise, you want to be able to have, to grab. So if I'm about to read a file, the first thing I want to do is check if it exists. If it doesn't exist, I want to say, hey, you're trying to get me to read something that doesn't exist. You've put in some bad data. These two Booleans are very useful because, again, as I said, a file object can refer to either a directory or to a file. And this way I can check to make sure that this file object, if I expect it to be a directory, and this can come in if I'm, say, either creating or reading something in a directory. I want to make sure it's actually a directory, because again, from a programmatic standpoint, I can't tell without checking whether a file object refers to a file or a directory. However,
Sir,
question?
All right, I have a question. So when you say parent file, is that the directory?
Yes. Yeah, so the name is a little, it can be, thanks for pointing that out. Okay, a parent file, the file here does not refer to a file in the file system. It refers to a file object that refers to the parent directory. So if I have any reference to a file object, then I can get the file object referring to its parent directory with get parent file. Does that make sense now? Yeah, in other words, the word file here refers to the class file, not to the fact that this is a file and not a directory.
But on the previous page as well, it said parent file. Is parent, the parent file is synonymous with a directory?
Yes, if I instantiate a file with this argument, a file followed by a string, then this has to be a directory. If this isn't a directory, I'll get an error. Because
is there like a time when you call one a directory and one a parent, or is it just it's used they just intertwine it wherever?
Well, the word parent is just that's just a variable name. It's descriptive in the sense that after I've created this file object, it points to a file, which could be a directory, whose parent file is this one. Okay, does that make sense?
Yeah, I think so. Because you just use like you say it's in the parentheses as well. It says parent file, name of parent. So when you say parent, it's just a parent directory.
Yeah, well, yeah.
Okay. I think, yeah,
Yeah, here when I say get parent file, I'm getting a file that refers to a directory. You see how it can get confusing, but it's that's why I'm trying to make sure to unconfuse. So hopefully I haven't confused more. So, and once we start working with it, you'll kind of you get a better sense of that. These are very useful things as well. So if I have a reference to a directory as a file object, I can say list files, and that will return an array of files that are the contents of that directory. This other one, this other form, and remember we talked about overloaded methods. This is an overloaded method. I can if I make it empty, it'll give me the files in the directory. But Java also provides an interface called a file filter. And a file filter will tell you which files it's going to list. So in other words, if I wanted to say, only list the files that have extension .txt, then I would write a filter that would say, only accept files whose name ends with .txt. Or let's say if I'm only looking for comma separated values. So, and I want to ignore all the other ones. So I can get a list of all the files that have a particular extension. That's the most common way of using these filters. Okay, so I want to, where are you? Okay. All right, let's see an example of this. And I want to do this in a new package. I'll call it IO because we're going to be dealing with the file system. Okay, so let's just sort of create one of these. Okay, so here's okay. Okay, well, the first thing I'm going to do is I'm going to, okay, you notice file is a class in the java.io package, as we can see.
Your fat-fingered user.
Yeah, thank you. Okay, there's a, we've seen, so far we've used system only to do print lines, but system actually has a set of properties. And one of the properties that it has is something called a user directory. So let's, assuming this works, let's take a look at, and okay, so let's just first see what that is. Okay, so the user directory is a pointer, it refers to a place on the file system where you're running the program. So every time you run, and this gets hidden a bit by the IDE. But whenever you run a Java program, there's kind of a stake in the ground, or the stake in the file system, as it were, which is when you were running, it would be as if we're running it from the command line. And this is where we would be running it from if we were running it on the command line, basically. So the user directory, you will notice that it actually points to a place on, which is the root of the project I'm running. So what NetBeans does is it has the user directory be where we're running it. And let's see what kind of thing it is. Oops, is directory. So let's see, is it a directory? It is a directory. Now, let's see if we can find its parent. Get parent file, okay? Okay, so we see that its parent, you see here, we were here, and its parent pointed to the one right above it. Well, we can see that it refers to that, but here's the thing, is, okay, so now let's create a new one. And let's use the, another one in the parent, or let's create it in the user directory. Okay, so it's, so let's see if this exists. So the new file exists, okay? Okay, so here's the parent, and then here's what I create. Here's this, the new one refers to this thing right here. And it says, does it exist? No, it doesn't exist. And we can kind of confirm that if we take a look here. So now what else can we do? Well, let's look at this list files thing. All right, so now what this does is this gives me an array of files, each of which should refer to all these things that I'm seeing right here. And like an array, I can use the for each to iterate over it. And let me sort of put a tab there. And now here's the thing is it notice that here, if I just print the thing out, it gives me the whole shebang. And if I don't want that, I can actually, if I just say get name, that will just return the name of the thing. And let's check to see whether it's a file. Okay, so here's what it listed. Okay, here's this annoying DS store that they keep putting in. Okay, here's the test. That has to do with something called unit tests that we're not going to get into, but it's actually something you should know about at some point. Okay, here's the dist file directory. So that's not a file. Okay, there's something called build.xml. That's right here. That's something that NetBeans uses to do stuff. Here's this README. That's a file. This is something called gitignore. Now that's been kind of created for you. And what that does is that makes sure that, among other things, see these build and dist directories. Those are things that NetBeans creates when it's compiling your program. And those are things that you really don't want to have committed to Git. So NetBeans knows that, and it says, okay, we're not going to see what. See, in gitignore says, ignore everything inside this stuff when I'm committing to Git. And that's because you really don't want that stuff in there. Okay, but that's a file that you may not have been aware of. Okay, here's the lib directory. That's not a file. NB project, that contains configuration stuff for NetBeans. We don't have to worry about that. That's not a file. Again, build. There's build, that's not a file. .git, now that's something that Git has done for you under the hood. It's a directory that has all the stuff that Git uses to do its stuff. That's not a file, and src is where all of our source code is, and that of course is not a file. Okay, so that's how we can locate things. Now, how can we filter things? Well, again, let's see. Java actually has things that do this. But remember, there was that file filter thing. Okay, why are you not? And notice I said implements. That tells you that file filter is an interface, and we can implement all the abstract methods. There's only one, it's called accept. And accept says, I give it a file, and I'm going to return true if it's okay and false if it's not. So for example, okay, supposing I only wanted to see XML files. The way I would do it, okay, I did a couple things here. Okay, what did I do? I said, okay, remember path, it says path name. That's actually badly named because it refers to a file, not a path name suggests that it's a string. It's not a string, it's a file. But as a file, it has a name. And name is going to be a string, and then strings have this method called toLowercase. That's going to put it all in lowercase. And as long as I'm saying if it ends with .xml, then I will accept it. And if it doesn't, then I won't. Now, just from a stylistic standpoint, this is the way to use Booleans. Sometimes you might be tempted to do something like this. Okay. This is like kind of not good style. Okay, so if you're doing something like this, then use a Boolean expression, not the if this then true else return false. 99.9% of the time, you don't have to do something like that. Every now and then you have to do some kind of test like that. But if it's just if you're just returning true or false, then use the expression that you're testing on to return. Don't just, don't do that whole the other dance. Okay, so how can we use this? Well, here, instead of listing the files with that, if I give it this extension filter, that's only gonna, this should only give me the XML file. And this is, of course, badly named. It should be called something more like XML extension filter, because it's this is not the most general thing to do. But again, just for an example.
So for that Boolean, so it's going to go into the, whenever you call it, it'll go into there automatically. And then it only gives the return if it's true.
No, it always returns.
Always returns.
It returns what the value of this expression is. This expression is a Boolean expression.
Oh, okay. I see what you're saying. Yeah.
And so that expression is either true or false.
True or false. Okay.
Yeah, what I'm saying stylistically, if you have an expression that's either true or false, and you have a method that's returning that, return the expression, not if expression then true else false. It's just a stylistic thing. I mean, and it's like, the difference between writing your thesis at, graduate school level versus writing your thesis at grade school level. Stylistic thing. I mean, again, if for some reason you like doing it the other way, I was kind of criticizing, you're not going to lose any points or anything, but just know that this is kind of a preferable way of really conveying what's kind of going on, and that you know what Boolean expressions are.
And then the accept, that's the method name.
Yes, accept is the method name, and under the hood, and we don't know exactly how it's doing it, but when I pass this to the list files method, as it goes down the list, I mean, you can sort of imagine what it does. As it goes through the directory of what files are there, with each file, it passes it to this accept method. And if it returns true, then it will put it into the array. Remember, we're returning the array. And if it doesn't, then it'll just skip over it.
And if you're just building a simple program, you don't necessarily need to create another class for XML extension filter. You can just make that a method.
Well, if you want to filter things, then you have to write a class. There's no way around that. Yeah, I mean, well, I say there's, if you use a feature of Java that we will not be, we won't be covering, called functionals, you could write a functional that would basically be doing that. If you know that, then that's fine, but we're not going to be covering it here. Okay, so and now there's also, just for our edification. What time? Oh, right. I'm running out of time. Okay, so now I'm not going to do that. All right. So those are the files, and now I want to talk about the next thing, which is a scanner. So it's okay. So now I have a way of getting a programmatic handle on things in the file system, but now I want to do something with them. Okay, and what's the main point of kind of working with the files is that I want to read them, I want to write them, I want to append to them, etc. So we're starting with reading. So the scanner class is actually one of the cooler ones, I think, that Java put in. It can interact with a local file or a remote URL. We won't do this quite yet. At some point, we'll maybe take a look at that. It's only useful for text files, again, not for binary files. There are a number of different constructors, but these are the two workhorses. One is I can give it a file in its constructor for a local file, or I can give it something called an input stream, which can be either local or remote. Now, before Java put in some very capable classes, when doing input and output, we had to deal with these lower level things like input streams are fairly low level. It turns out here we actually don't have to work so much with the bare metal. We can actually use some of these higher classes to do the, as you'll see, when we use a remote URL, what we do is the URL object has a method called OpenStream that'll give it the input stream that corresponds to that URL. And then, so we don't actually have to worry so much about what the specifics of the input stream are, but that's just FYI. So here are some useful methods in the scanner. Mostly what I found is that just kind of working with it line at a time is kind of the ideal way to interact with it. But if I want to work with some of the individual things, what it does is it breaks the text up into tokens, and each token is separated by a delimiter. The default delimiter are spaces, like tabs and spaces and stuff like that. And so when I say next, if I say get next, that'll give me the next string. If I happen to know that the next thing is an integer, I can say next int. If I happen to know it's a double or can be parsed to a double, I can say next double. These can be dangerous to use because if they don't parse right, for example, if I say next int and it actually has a decimal point, then I'll get an error, a runtime error. If it can't be parsed at all into a number, these will give errors as well. So I actually tend to avoid those. And then finally, close. Whenever you're interacting with the file system, you always want to you always want to close it when you're done with it. Okay, so what does that look like? Let's okay, so do something a little bit weird here. Well, Okay, so what I'm actually doing, so here's where I want to make sure that I've actually pointing to the right thing. And so here's here. Okay, well, what I'm going to do is, this is kind of a snake eating its own tail. I'm actually pointing to this source file on the system, and just one check that I recommend is to sort of check to see. First of all, say this is what it is, and if it doesn't exist, because I might have fat fingered the file. So I want to say, okay, if it doesn't exist, then let's put this after that, because that says if I, let's put it, oops. Okay, so let's see if we've actually found it. So it says file not found. Okay, so why didn't it find it? Okay, so that I forgot to put this in. Okay, now notice that this is a relative path, and this is actually why you always want to do this. So it says, look, this file doesn't exist, but now it found it. Okay, so let's read it in. So how do I read it in? I create a scanner. And I give it the file. That's one of the constructors. And again, red squiggly, can't find symbol, fix imports. Okay, now I'm still getting a red squiggly, and what it says, unsupported exception. Now we're going to talk about exceptions later in the course, but for right now, we'll just kind of follow the suggestion. And the suggestion here is where it surrounds statement with try catch. In JavaScript, you should have encountered exceptions. Is that true? Well, if you didn't, okay. So you know what you should have a vague idea of what an exception is. We'll talk about exceptions, and then here we. Okay, so again, oops. What I need to do is put this outside here. Put this inside here, and then close it. Might not have been initialized. Okay, so. All right, let's. Okay, so now, so we just have time to just kind of read this sort of thing. There are a couple ways to do this. One way is a for loop. Okay, so here I'm. Okay, so let's just sort of print it out. So notice what I'm doing is I'm pointing to this file itself. And when I run it, it actually prints out exactly what I have here. So, and that's all the time I have for today.